Welcome back to the deep dive. We're here again, pulling the strategic intelligence you need straight from the research. Today we're kind of strapping on our virtual hard hats. We're charting a course through the pretty high-stakes world of modern architectural project management
Yeah.
and construction.
Yeah, and this dive is definitely strategic. Our mission really for you today is to get a handle on the, let's call them foundational structures that govern these big construction projects.
Okay.
We need to look at how teams are actually contracted, how the work typically flows through phases, and maybe most importantly, how all these new digital tools like BIM, building information modeling, and VDC, virtual design and construction, are forcing this really huge, urgent shift towards collaboration, yeah, but also efficiency and sustainability.
Okay, so it sounds like we're moving beyond just, pouring concrete and framing walls. It's more towards optimizing the whole life cycle of whatever's being built.
That's exactly it. The core insight, I think, is that the decisions made really early on, both the design choices and the contractual setup, they now have the biggest impact over the total lifetime performance, the cost, everything of that building or infrastructure.
Right.
So to really succeed now, you've got to look at two structures at the same time. The structure of your team, how they work together, and the structure of your information, how it flows.
Okay, that makes sense. Let's unpack the team structure first then. You mentioned project delivery methods. So this choice sounds pretty fundamental. It dictates how risk and responsibility get shared out between the owner, the design team, the builder.
Absolute foundational. And we kind of have to start with the traditional default, design, bid, build.
The
DBB.
For the classic one.
It's the classic model, yeah. The owners sign separate contracts, one for the design team, one for the builder, the contractor. The design gets completely finished first, then is put out for competitive bids.
And the supposed advantage there is what? A lower initial price tag because everyone's bidding against each other?
That's the perceived advantage, yeah. Lower cost due to competition.
But the drawback is almost legendary in the industry, isn't it? Because the design's totally done before the contractor even sees it. You get zero feedback on whether it's actually buildable efficiently up front.
Precisely. Zero constructability feedback, which means the owner is immediately vulnerable to, well, budget-busting change orders and often crippling delays once construction actually starts. It's baked into the separation.
That separation, it naturally leads to a very linear step-by-step process, right? Which connects to those traditional phases of architectural service that fit perfectly with DBB.
Exactly. That sequential workflow, it starts with schematic design, or SD. That's where you define the basic program, the project goals, spatial layouts. Cost is usually estimated pretty broadly, often just based on the building's volume or area.
Okay, so big picture first.
Yeah. Then you move into design development, DD. This is where things get more specific. You're nailing down material types, figuring out exact window and door locations, locking in the main MEP, mechanical, electrical, plumbing, and structural systems.
Getting more detailed.
Right. And finally, the big one, construction documents, the CDs. These are the highly detailed drawings and specifications, everything needed for final pricing and, actually building the thing.
So SDDDDCD, it feels very rigid, one step after the other.
It is inherently rigid. Now, compare that to the first real step towards integrating things, design build, or DB.
Okay.
Here, the owner signs just one contract with a single entity for both design and construction.
Ah, okay. So the builder and designer are on the same team from the start.
Effectively, yes. The immediate benefit is usually efficiency, and often dramatically shorter timelines because they're forced to collaborate from day one. The builder can give input during design.
Sounds much better for speed. But where's the catch? Does having just one contract create like a conflict of interest?
It absolutely can. That's the main risk. The design-build entity, they're naturally motivated to keep costs down, right? Which might compromise the quality or the specific features the owner was really hoping for.
Right, because their profit is tied to saving cost.
Exactly. Our sources do mention something called progressive design build emerging to help with this. It's basically a two-stage approach. There's an initial phase for design and pricing, and then kind of an off-ramp if the owner isn't comfortable with the direction or the cost estimate before committing to the full build. It reduces some risk.
Okay, that makes sense. So moving into even more complex, maybe more collaborative structures, we have construction manager at risk, CMAR.
Right, CMAR. This is different again. Here, the construction manager, the CM, gets involved very early, acting almost like the owner's expert representative.
But they take on risk too.
Yes, that's the at-risk part. Their main job early on is cost control, constructability advice. and they typically commit to delivering the project under a guaranteed maximum price, a GMP.
Ah, the GMP?
So the CM takes on the financial risk for exceeding that budget or missing the deadline. This makes them deeply invested in efficiency, scheduling, finding savings, which is obviously a huge plus for the owner.
Okay. And then there's what sounds like the sort of ultimate collaborative model. Integrated project delivery, or IPD.
IPD really flips the script. It completely restructures the relationships. It tries to move everyone beyond just fulfilling basic contractual duties.
How so?
Well, IPD is unique because all the key players, the owner, the architect, the main contractor, sometimes key engineers or subcontractors too, they all sign a single multi-party contract right at the beginning.
Wow, okay. One big contract for everyone.
Yeah. And they share the risk and the reward together, equally. If the project comes in under budget and ahead of schedule, they typically share in those savings. If there are overruns, they often share that pain too.
So everyone's incentives are perfectly aligned.
That's the goal. Maximize efficiency, innovation, collaboration, because everyone wins or loses together. It's about the project outcome, not just individual company profits.
Okay, let me try and connect this strategically then. If my main goal is, say, maximum efficiency, and I want to integrate all this sustainability data we're sharing about and use powerful cost modeling like that 5D BIM we'll get into, which contract type makes that easiest? Is it the old DBB or something like IPD?
Oh, it's IPD. Hands down. Or potentially a well-structured design build. DBB, because it enforces that strict separation between design and construction, makes real-time data sharing, integrated cost modeling, that kind of stuff, extremely difficult, sometimes impossible.
Because the teams aren't incentivized or even contractually allowed to share that openly?
Pretty much. IPD, by its very nature, facilitates the open information flow, the trust, the collaboration that you absolutely need to run these modern integrated digital tools effectively. The contract enables the technology.
That makes perfect sense. The contract structure literally shapes how the data can flow. Okay, let's pivot then. Let's dive into the technology that's kind of smashing that old sequential process. Building information modeling, BIM, the digital backbone, you called it.
Yeah, BIM. And it's crucial to understand it's more than just a pretty 3D model. It's a digital representation of all the physical and functional characteristics of whatever's being built.
Okay.
Think of it like a reliable shared database, a knowledge resource that stays with the project through its entire life cycle, from the very first concept sketches all the way through operations, maintenance, and eventually demolition or repurposing.
And we talk about the dimensions of BIM, right, to describe how much information is packed in there.
Exactly. So beyond the basic 3D BIM, which is the geometry, the shapes,
The visual model.
right, we then augment that geometry with information attributes. So for every object, like a window or a valve, you might have the manufacturer's details, the model number, installation instructions, warranty info linked right there in the model.
Okay, so data attached to the geometry.
Precisely. But the real power starts to emerge when you add more dimensions, like 4D BIM.
And 40 adds time, right?
Right.
Scheduling.
Exactly. Time, scheduling. You link the 3D model elements to the construction schedule. So you can literally watch a digital time-lapse simulation of the entire construction process weeks or months before anyone sets foot on site.
Wow. So you can spot problems.
Big time. You can see potential clashes like, oh, the plumbers and electricians are scheduled to be in the same tight ceiling space at the same time, or site logistics issues like crane access or material laydown areas. You spot and fix these bottlenecks virtually before they cost you real time and money in the field.
Okay, that's huge. And then comes the money aspect with 5D BIM.
Yep, 5D adds the dimension of cost. By linking the geometry, which knows quantities like how many cubic meters of concrete or linear meters of pipe, to specific cost information from a database.
The model can basically generate cost estimates automatically.
Pretty much in real time. As the design changes, the cost estimate updates. You get instant quantity takeoffs. McKinsey identified this capability years ago as a massive disruptor because it completely transforms how estimation and cost control work. Much more accurate, much faster.
Incredible. And then quickly, 60 BIM.
60 is generally seen as adding the dimension of lifecycle management. So information needed for operating and maintaining the building after it's built. Things like maintenance schedules, energy performance data. Sometimes it's also used specifically for tracking sustainability metrics.
Got it. So BIM is the intelligent model, but you also mentioned VDC earlier. How does that fit in?
Right, so BIM is the model, the what? Virtual design and construction, VDC, is the how. It's the methodology, the process framework that actively uses that intelligent BIM model to achieve specific project goals.
Okay, the definition we had looked pretty academic. Can you break down VDC in simpler terms?
Sure. Think of VDC as the structured system. The meetings, the workflows, the tools, the metrics that turns all that raw BIM data into actual measurable performance improvements on the project. It's about optimizing towards specific business objectives, whether that's speed, cost, quality, safety, or sustainability.
And it uses specific techniques.
Yeah, it pulls in concepts from lean construction, like minimizing waste. It also uses planning systems like the last planner system for reliable scheduling. It relies heavily on collaborative work sessions, often called integrated concurrent engineering, or IZ sessions, where different disciplines work together in the same room, often on the same model, in real time. And crucially, it uses metrics to track progress.
Okay, this sounds almost essential for complex projects today, yet our sources mentioned a warning about something called BIM wash. What's that about?
BIM wash. Yeah, it's basically making misleading claims. It's saying, oh yeah, we do BIM, when all you've really done is bought some 3D modeling software.
But not change the process.
Exactly. You haven't actually committed to the collaborative workflows, the open data sharing, or using agreed-upon data standards that are necessary to actually exchange information reliably between different teams and software. It's BIM in name only.
So it's like putting a green label on something without doing the real sustainable work. How do clients protect themselves from BIM wash?
That's a great question. They protect themselves mainly by requiring compliance with neutral, non-proprietary data standards. Things like IFC, which stands for Industry Foundation Classes, or COBE for Handover Information.
Oh, okay.
Requiring these standards forces the project data to be structured in a way that it can actually be exchanged and used across different software platforms. It ensures the promise of BIM, that shared knowledge resource, isn't just locked up inside one company's proprietary software. It demands real interoperability.
Got it. So if IPD and VDC are delivering this potential for efficiency, what's the single biggest goal that efficiency needs to be aimed at right now?
Our sources were pretty clear on this, the sustainability imperative. The stats are,
Ah,
well, they're quite sobering.
they really are. The global buildings and construction sector, it accounts for around 37% of energy and process-related CO2 emissions worldwide. 37%.
Wow.
I mean, if we're serious about tackling climate change, this industry is arguably the most critical pressure point. We have to change how we design and build. And the research really hammers this point home. The time to make the biggest difference, the biggest carbon cuts, isn't during the actual construction phase. It's much, much earlier. It's right now during design.
Yeah, this is shown really powerfully by something called the carbon reduction curve. Basically, it shows that your potential for reducing carbon is greatest, maybe up to 100% theoretically, during the earliest planning and design phases.
Before decisions get locked in.
Exactly. Once you get to those detailed construction documents,
Yeah.
your flexibility, your ability to make significant changes to reduce carbon, it just plummets. The big decisions are already made.
And to make those decisions well, we need to think about two different kinds of carbon, right? Operational versus embodied.
Correct. Operational carbon is probably what most people think of first. It's the emissions from actually using the building, heating, cooling, lighting, power, water systems, ongoing maintenance. But embodied carbon is the carbon footprint of the materials themselves. It's all the emissions generated from extracting raw materials, manufacturing building products, transporting them to the site, the construction process itself, and eventually their end-of-life disposal or recycling.
And since those material choices happen early in design,
Controlling embodied carbon becomes a primary task for the design team today. You have to choose lower carbon materials right from the start.
so the solution seems to be using technology differently, not just analyzing after the fact, but designing with the outcomes in mind, this outcome-based design idea.
Exactly. It flips the old model of design something, then check if it works. We now have generative design tools that can integrate data on cost, carbon, energy use, daylight, whatever, while the design is evolving.
Can you give some examples?
Sure. Pick something like Autodesk Forma. It's designed for early-stage planning and conceptual design. It gives architects and planners almost real-time feedback on things like solar exposure, wind patterns, noise levels, and crucially, embodied carbon estimations based on massing and material choices.
So you can compare options really quickly.
Instantly. You can rapidly compare, say, 5 different massing options and see their predicted carbon footprints side by side before you even get close to detailed modeling in something like Revit, which Forma integrates with.
Okay. That sounds powerful. And another one mentioned was test fit.
Yeah, Tested is fascinating. It specializes in super fast feasibility analysis, particularly for things like multifamily housing or industrial sites. It uses algorithms to generate buildable site layouts and building designs in literally seconds. Yeah,
Seconds.
it's incredible. But it's not just layouts. It integrates real-time constructability checks and, importantly, cost metrics, that's 5D, again, right into the tool. So you can evaluate the financial viability of a deal, iterate on designs, and understand the cost implications almost instantly. It collapses what used to take weeks or months into potentially an afternoon. That speed is transformative for deal evaluation.
Wow. Okay. And beyond new builds, we shouldn't forget about existing buildings, right?
Hmm.
Adaptive reuse.
Absolutely crucial. Renovating and repurposing existing structures with adaptive reuse can slash the embodied carbon impact dramatically. We're talking 50% to 75% less embodied carbon compared to tearing down and building new.
And tech helps here too.
Definitely. Tools like Recap Pro, for example, use laser scanning or photogrammetry reality capture to create highly accurate 3D models of existing buildings. Having that precise as-is model is essential for architects and engineers to plan renovations and additions effectively and efficiently.
Makes sense. Okay, so if we're adopting these integrated methods like VDC and we're focused on outcomes like carbon reduction, then just measuring success by the final cost and schedule at the very end. Those traditional lagging indicators, that's not really enough anymore, is it?
No, it's really not. It tells you if you succeeded after the fact, but it doesn't help you improve the process while it's happening. For VDC to work, to drive that continuous improvement, you need leading indicators, metrics that measure the health of the design and planning process itself.
Okay, so what kind of metrics are we talking about? Our sources highlighted a few key ones for the design phase.
Yeah, there are several, but maybe three core ones to focus on. First, something to measure planning reliability.
Okay.
That's often percentage plan complete, or PPC. It's simple.
hmm
You look at the tasks the team planned to complete in a specific period, say the next week, and you measure what percentage they actually completed.
So it forces accountability for planning.
Exactly. A consistently high PPC indicates good planning discipline and reliable workflow. Low PPC signals problems you need to fix.
Okay. Second, measuring the quality of the digital model itself to prevent downstream problems.
Right. A key one here is the number of clashes detected in the BIM model after reaching certain milestones or maturity levels. You run automated clash detection looking for those geometric conflicts we talked about earlier.
Like pipes hitting ducts.
Exactly. You'd expect the number of clashes to decrease steadily as the design progresses and coordination improves. If it's not decreasing, or if it spikes, it shows coordination isn't happening effectively. Tracking this helps ensure a higher quality, better coordinated design before it gets to the site, which means fewer errors and faster work there.
Makes sense. And the last one sounded more behavioral, targeting decision making.
Yeah, this one's really interesting. Decision latency and stickiness. Latency measures the time it takes from when a decision is requested from someone, often the client or a key stakeholder, to when that decision is actually made.
So how long are people taking to decide?
Yep. And stickiness measures how many times that same decision gets revisited or changed later on.
Okay. So high latency means slow decisions and low stickiness means decisions keep getting changed.
You got it. High latency and low stickiness are often signs of poor client engagement, maybe unclear project goals, or just systemic indecision. VDC aims to tackle this head-on through things like structured workshops, clear documentation, and getting the right people in the room together to make timely, informed, and sticky decisions.
This has been really illuminating. It really shows how all these pieces, the contracts, the process, the technology, the goals like sustainability, they all have to connect. The key lesson seems crystal clear. The best path forward, the most efficient and sustainable one, relies fundamentally on choosing the right kind of collaborative delivery method, first like an IPD or maybe a progressive DB, and
Yes,
then absolutely underpinning that structure with integrated digital practices, BIM and VDC, right from day one. You can't bolt it on later.
it's exactly right. And maybe the final thought, the strategic synthesis for you, listeners, this. The contractual structure you choose, like IPD versus DBB, increasingly determines your capacity for the necessary digital integration. And that digital integration, using BIM and VDC effectively, is now pretty much non-negotiable if you want to meet modern demands for efficiency and hit those critical sustainability targets, especially around carbon.
So if your contract actively prevents or discourages collaboration and open data sharing,
You've essentially handicapped yourself before you even start. You've made it incredibly difficult, maybe impossible, to harness the real power of things like 5D BIM for integrated cost and carbon analysis throughout the project lifecycle. The contract enables or disables the tools.
Wow. So the challenge for everyone listening as you look at your next project is to ask, are the contracts and the chosen delivery method designed to enforce the old silos and separation? Or are they specifically crafted to facilitate the real-time data sharing, the collaboration, the integrated decision making that makes actually measuring, managing, and reducing carbon not just a goal, but an achievable reality? That feels like the foundational question for building better tomorrow.